And welcome back. Picking where we left off last time in Factorio, where we're going to pick up with trying to build out our utility science production. Ideally, if we want everything to be properly balanced, for down here, we need enough to make 7.5 per minute. I think we're still being throttled by the steel on those furnaces, yeah. Which is just how that's going to be until I can sort out more iron production. How is the Bob Fizzle? Rearming. Mostly rearmed. Okay. So with that, we can probably say go to Vulcanus, pick up not some foundries, some big miners, big miner drills for us. There are 100 there. Our capacity is 20. Let's say pick up 100. And then hopefully remember to come back and fix that before it gets torn to shreds by asteroids. So yeah, we're going to make 75 of the utility science. This by default makes 3 per input here, so that means we want to make 7.5 low density per second, 2.5 flying robots, and 5 processing units per second. Which actually shouldn't be too hard. So it's basically half a belt of low density, half a belt, well, less than half a belt of blue, and less than half a belt of flying robot flames. Let's start with the low density. So low density is that recipe. So it's 15-second crafting time. Presumably we're using assembly machine 3s, which we might as well. It means if we make 15 assemblers, we'll make 1.25. And we want to make 7.5, so 5 times 15, so 75 assembling machines. They're not running very fast, but we need a lot of them, is what that's basically telling me. Unless I'm screwing up the math. 1.25 times 2. Yes, I'm screwing with the math. No. 2, 4, 6 would be 7.5. Then times the 15. Okay. 6 times 15, 75. Yeah, 75. Needs to say that's a lot. That is a lot. Taking a little bit down to damage is not a problem as long as nothing breaks. I forgot what the length of this is. Red. 5 seconds would be 5 times. Well, 7.5. Okay, yeah, so can't remember the number. I think that was like 20 something. Yeah, let's just an assembly setup that is 15 long. And then we'll just double it. Well, copy and paste it a couple times. 2, 3, 4, 5. 10, 15. We worked out we need 75, so copy that, go say that wide, that long. 5 times. Something like that. That's implying that's probably not where we want that then, because that's taking up too much space in a spot where, well, we've got the space, but we don't have the space for feed in, feed out, which is an entirely different logic path. Alright. Obviously, keep this all powered. We'll have to come through, move the power poles a bit. Just overwrote. And that shouldn't initially have too much problems. I do have a little bit of redundancy in it. Hmm. Oh, wait, this might not be enough space. I might need to shift up, down, 1. Yeah. Probably need another space in the middle. Okay, and over here we worked out that we need at least 2 belts of throughput. Almost deleted the thing I didn't want it deleting. Which would have been easy to fix. We've just been dropping another starter in, but okay. Now, this is intimidating in its own way, because that's a lot of copper. So we worked out we need 7.5 low-density structure. So basically half a belt of low-density structure, which then means we need 10 whole belts of copper. Yep. Might be overscaling this a bit. Well, saying overscaling it for what we're thinking about, probably. Like, this is big. This is going to be over-designed. In the long run, it'll be nice, but short run, it's probably going to be a little overkill. So 5 half belts of plastic, and not even a half belt of... Well, 5 half belts of plastic, and a full belt of steel across all 5 of these lanes. So we're definitely going to have... It's going to be 10 yellow belts across 5 lines. So... Yeah, I need a red line on each. Okay. Red is... the copper. Oh, maybe I'm gonna need more space in the middle. Already worked out I need more space in the middle because I need space on both sides. Because this one can't share, or this one can't share with that one, otherwise we don't have enough throughput. Yep. Worked that out. Move the power poles again. Okay. Back to the high-speed belt. This is the copper line. Oops, too far up. That's where I need it. And then we're gonna have a yellow belt in the middle, that'll be the other stuff. Could probably be more space efficient. Than I am going to be. We'll just work with this. Ba-bum. I'm realizing that the ideal world would have been to have space on these, but we'll make it this way. I didn't leave enough space. Which is the origin cause for all the spaghetti is you didn't leave enough space. Often. Didn't leave enough space for the optimal design, so you spaghetti a solution together. And this is just one of the 3 components. We need even more. I do have to say, when doing this sort of work, it's nice to hear the chirping of the worker robots. Okay, so that's that row. We need some regular built in here. I'll need to hook that up. Otherwise, when the whole thing gets put together, it's not going to work. Then the long-handled. Okay, let's see. Have Navis, have you... Vulcanus, you're loaded, so come back to Navis, please. Or you take too much damage. Basically future thinking about the fact that I'm going to need a whole lot of more throughput for mines and furnaces and stuff. And the easy solution is big miners. Okay. Let's see, can we do a quick copy? Paste. Critical swap, yes. Okay. Critical swap. Particle swap. Okay, yeah, it's gotten a lot of the work done. I just need to come back and fill in the few whoopses from the irregularities in the assembly. So I'm doing this backwards. Take out of the assembler, because you assembled to that point. Okay. And here, that row as well. Okay, I think that's worked for most of it. Yeah, looks like it worked for most of it. Bringing the belts a little bit together so we can simplify delivery. So, half a belt of plastic per line, and the 5 are sharing a full belt of steel. Yeah, okay. So, something like... No, we need, well, actually, like that. Cross. Underground. Yeah, close enough. The, save there. Didn't hate some of my button clicks. We're gonna have an underground here, like so. Oops, no, that one's being regular. Yellow. So, and you can hop across like so. Okay. So then the unattached wings here are our plastic ends. Need half a belt of plastic on each. Which basically means we need a quarter belt of coal. So it's basically a whole belt of coal. Um, right, so we need... Oh, each of those need a belt of plastic. Five belts of plastic means we're going to need 5 belts of... Well, 5 half belts of coal, so 2.5 belts of coal. That's the thing for coal, so let's do the copy. That's probably the most generic setup. Now we can fathom. 2 belts of red between it. 2 belts of red between this one and that one. Oh, I need that one because it's in the wrong spot. One more space. So it's 1, 2 for the red, 1 for the steel coming through. 1, 2 for the red. Actually, let's do 3 for the red as well here. Plop it there. I'll go down to there, then we need access to that one. And that one. Okay. We need one down there. So. Okay, so that's what we need for plastic. So we got, well, that's a half a belt. So we could do a little bit of Italy stuff to make that work. I may actually have overkilled this. Which 1 second makes 2. Yeah, I've overkilled it. I've overkilled to kill it. Okay. Do I want to fix that? Probably fix that. So I need 5 belts of plastic. I've just made production for... Well, I need 5 half belts of plastic. Just made production for 5 whole belts of plastic, so that's officially twice as much as I need. Okay, that's actually fairly easy to fix. We'll just do that. Get rid of that. Leaving some extra space in the design is not going to hurt too much. I got rid of the feed belt there. Alright, that should give us an idea whether or not I've completely screwed that up. I wish you need to hook it into power. By screw it up, I mean run the petrol too far. And obviously each of these needs a half a belt of coal. So that's too hard to do. In fact, what? So that's yeah. So that's a half a belt of plastic, which needs a quarter belt of coal. But that'll work. Yeah. And then underground there. Okay, there we go. For that bit, I don't actually have any through the middle there, so just go up like that. And yeah, that one technically needs like a quarter belt of coal, but it's gonna probably end up with a whole belt. Well, we can just accept that the system will be a little inefficient and just go through like this. We're gonna have other inefficiencies. The whole thing's gonna get redesigned at some point. It's plastic. Apparently we're gonna get cryogenic plants at some point, which is probably better than the chemical labs that we're using. Straight up. Yeah, probably. Okay, so steel, steel. Coal coming in, steel, copper, copper, steel. Copper, copper, copper. Yeah, okay. So that's 10 furnace stacks of copper. So where I'm going to find the space for that is an entirely different problem. Or back in orbit, yes? Bomb fizzle? Yes, okay. Please drop those to Navis. Waiting for the cooldown. Ship these. Probably going to ship this back out to Navis, or out to Vulcanus to pick up more miners. Okay, apparently I screwed up the drop, which is why I was taking sweet time to do the delivery. So they're going to land right next to us. We'll probably spend a bit of next episode just going around upgrading mines. What I might try to do is basically build a balancer, massive balancer. So that I don't necessarily to build more mines, because, yeah, we need like 10 more things of copper, 2 more things of, well, 2 more things? Yeah, 2 more things of steel. No, 1 thing of steel. 1 thing of steel, 2 things of copper, or 10 things of copper. Just to get that going, and then we've got more. We got more. Processing units, blue, and robot flames and stuff. And yeah, we're not going to get more mines, we're just going to make them more efficient. So we're going to basically try to rely on the trains to go faster and faster. Which really is just balancing, I think we need to balance so all the trains are running roughly the same. And so that the furnace stacks that we have are properly running. At some point we'll tear out all the furnace stacks and replace them with foundries, but we need calcite, and to get calcite we need the science that we want to feed with the foundries. Because yeah, I think the melting recipes, you go through a decent amount of calcite. 1 calcite for 50 iron ore. 50 iron ore becomes 500 molten. Right, so it's a 1 to 10 ratio, and then a 10 to 1 ratio. I'm trying to decide, well, we have a productivity step and a productivity step, right? So the net effect is that you're gaining iron. Right, so foundries have plus 50% productivity. So doing this to that, and so you get 50% productivity on that, you get 50% productivity on that. So it's net product, but obviously you need the calcite, so you need to feed the calcite in to do that. We're not equipped to do that right now. So there, again, there are lots of potential savings using the foundry to do all this stuff, but then we need to be able to make molten stuff. There are some things that we can do straight from the foundry, but those are mostly the belts I think we can assemble in the foundry. That's assembly, so yes, we probably would be a benefit, but we don't actually need very many belts. Most of the stuff we can make in the foundry, I believe, isn't going to make sense unless we got molten down here. Okay, so we can see we have a steel problem because we don't have enough throughput of steel or of iron coming in. I think the iron's even a little bit holy, which isn't super good. Oh, because it's getting split up there, yeah. To make more steel. So yeah, I think I need to do a balancer. I'll probably look up a really big balancer. And try to feed all the trains into a balancer, and then the balanced output into the base. I may load up between streams just to get a count on how many lane balance I need the balancer to do. So we get the whole thing running a little bit faster. Yeah, so we got... Well, we haven't built the furnace stacks for it yet, but basically we're thinking about... That's basically that build. It's just the furnace stacks, coal input, and the steel and copper furnace stacks in. And that's actually probably the one we need the most of. Then it's over to processing units. Is the next most. Does look like it's going to be the same number from using machine 3s, the same number of assemblers to make these. And then that's blue into red into green and of. So one question is, would it make sense? Because I think the only one we're missing on assembled down here, well, we're not missing it because we have it down here. Right here, we're making very limited artisanal flying robot frames. We could probably queue up and make a very small science thing down here. Oh, of course, it's just not quite enough to go to the space station. Alright, and then what we're missing is some robot flying frames, which we'll probably just sort of Artisanally build here. There's no way this is going to have enough throughput to run very much, but, you know, sometimes you just don't want to run very much. Okay. And I even have a belt to take it. Oops, we got the space science on it. We'll fix that. For that, well, there's a lot of stuff that's going to unlock for us, just getting a little trickle of the orange in. Well, I say orange, yellow. Yellow in. A little bit of the trickle yellow in. Let's set up. You only pick up the space science, because we're basically going to pack space science back up again. Okay, in theory, we now have some artisanal, very small batch made yellow science going. As the bots catch up. So yeah, that production line scaled to the moon is what we really want to do in the long run. But in the short run, this will work. Not sure. Well, I suppose I could just save up 2,000 and ship 2,000 over to Bulgura, and we can just force the asteroid processing through. And done, so that's flowing. You know, all this is running off of a single battery maker. Yeah, we're gonna have other problems. But for the moment, it's working. Yeah, next episode we'll go and do some mines upgrade with the big miners. We might see about trying to do some orange research, now that we got some very limited capacity for it. Focusing on qualitative improvements. Maybe taking things like picking up the portable fission reactor so that our suit of armor works better. We're going to need that at some point if we want artillery, power armor Mark II and stuff. This is pretty small scale. It's like 150 of that, 200 of that. Right, we can pretty trickle in. We've been working in thousands of the purple, right? So we can work a few hundred of yellow. Just to get some of the basic stuff done, like the portable fission reactor. Yeah. But that will be next time. I've been streaming for 3 hours. It's 2 a.m. in the morning. I let this part go up to 50 minutes, so I should probably go ahead and put the part break in here. And I can come back and futz with trying to make the base more efficient. One thing we might want to do is go out to Fulgura and troubleshoot how this is running and to make some more electromagnetic furnaces. It might be interesting to grab these for things that they can make. That's no. We'll leave that on electromagnetic furnace. I can. Right. I'll go with science here. So, for example, the electromagnetic furnace has all these things it can make. Basically anything that's circuitry related, so all the power poles, beacons, and all the circuit boards, the defenses and stuff like that. It specifically, I think, needs to make the electromagnetic science here, but we can make everything else here as well. Something's gummed up in the works here that's making it not work, right? So if we go back to Fulgura and make Fulgura, we can get some electromagnetic science. And for some of the stuff, this is going to be much more space efficient. Because this is got a crafting speed of 2, so this is 2 of us. So it's just a straight multiplier 2, and it's got 50% productivity on it. Inherent productivity. Which I suppose technically means it's got a crafting speed after you count for the productivity of 3. Right, so that's almost 2 plus assembly machines for situations where you want to use that. And that has definite uses, right? So we can use that to replace all the wires. Actually, not all the wires. The wires have to come out of foundries, right? But, for example, we just said it's got a production speed functionally of 3. So you can replace all 3 of those with 1 electromagnetic one. And we have lots of situations where we've got some amount of green, so that would be 2 electromagnetic cleanse, right? And that reduces the input, so you need less input, so if you've got everything balanced, better, more efficiency, more productivity. So we're probably what we're going to run around and start doing. Yeah, that'll be next time. So if you are watching YouTube, I'm recorded far enough ahead that there should be a part up by tomorrow, but